Alrighty. Good afternoon, folks. We are here on lesson 3 of our chemistry series, where today we're going to look at chemical bonding. Okay, so let's jump into it. Alright, so when we talk about chemical properties and when we think of chemical reactions and how things react with one another, on a surface level you kind of see those chemicals interact with each other, but at an atomic level, really what it comes down to, when chemicals react with one another, it actually comes down to their valence electrons. Okay, now what that means is that atoms, when they interact with other atoms, that is the basis of a chemical reaction, and they can do one of 3 things as it happens. Okay, the atoms between each other can either lose valence electrons to other atoms, they could gain valence electrons from other atoms, and you can see how one loss is another one's gain, or in the third level they can actually share electrons with one another. Okay, and so when the electrons from one atom interacts with another electron from another atom, they form what we call a chemical bond, right? And so that's in definition what a chemical bond is. A chemical bond is an interaction between electrons of different atoms. Okay, and depending on how the electrons interact, we have a different type of bonding. Okay, so now the 3 main types of bonding, which are not particularly covered in the general science course, but in the advanced science course, are number 1, ionic bonding, where one atom will give its electron to another atom. Number 2, covalent bonding, where 2 or more atoms will share electrons with one another. And number 3, metallic bonding, when multiple atoms will share a large group of atoms, or a large group of electrons, or a sea of electrons. All right? And that's where metals come from. Okay. Now, all of the following examples are basic versions of ionic bonding, because at a fundamental level, you don't really need to know specifically how it works. We're just going to show you examples of understanding how a reaction works and how the electrons actually has that interplay with one another. Now, to see and understand the detailed parts of each of these types of bonding, you do need to do the advanced science course, but for the time being, we're just going to go with basic versions of ionic bonding. Okay. All right, let's give an example. So this is sodium, right? So sodium has the chemical symbol Na, and sodium has electron configuration of 2, 8, 1. You can see 2 in the first shell, 8 in the second shell, and then 1 in the third shell. Now, if you look for sodium in our periodic table, you're going to see that sodium sits right there. Now, when we looked in the last lesson and we looked at the periodic table, we could see that these groups here, 1, 2, the transition metals in the middle, 3, and bits of 4 and 5 and 6 are all groups of atoms that like to give electrons. So based on that, we know that sodium is going to want to give away that 1 electron. Okay, so when we come back and we look at the configuration, right? That 2, 8, 1, that valence electron, that's going to be given away, right? And so sodium's just going to give it away. And when it does that, because it gives away electron's a negative charge, it's going to become more positive, right? And so Na becomes what we call Na plus, or more specifically Na1 plus. That 1 represents how many electrons it's given away, and the plus tells you what its remaining charge is. Its remaining charge is positive because the electron is negative and you've given away that negative charge. So Na plus is what we call an ion. It's no longer called an atom, it's called an ion because it doesn't have a neutral charge, right? It's got a different charge now, and in this case, it's a positive charge, right? Now, chlorine, on the other hand, if we take a look at chlorine, chlorine has a chemical formula of Cl, an electron configuration of 2, 8, 7, and chlorine sits so that was Na. Chlorine sits down here. You can't really see it, it's getting blocked, but chlorine sits in the pile where it likes to take electrons. So now we see an opposite pattern happen, right? With 7 in the outer shell, 1's 8, so it's going to want to take an electron and form Cl in the opposite way, minus, or Cl1 minus. By the way, minus and 1 minus mean literally the same thing. It's just that scientists got a little bit lazy. Rather than writing 1 minus every time, they just wrote a minus, okay? So they're interchangeable for 1. When it's 2, it becomes 2 minus and so forth. But in this case, you really only need to know the 1, okay? Now, turns out though, if you put chlorine and sodium together, they're actually going to, sodium's actually going to give that electron away and chlorine's going to take that electron. And that's a chemical reaction that happens, okay? There's a video that you can watch which shows this process happening. I'm not going to show that video. You can watch it kind of in your own time in the PowerPoint. But basically, what you're seeing is that, oh, sorry, let me go back one step. What you're seeing is that glow there, that's the reaction. That's what we actually see happening, okay? So in this diagram, you can see that sodium is going to give its one electron to chlorine, and then the two are going to bond together. See that electron that's just moved? It's going to join together as a result, and there's your chemical bond, right? There's your chemical bond, and those two are now one molecule, right? One molecule containing two different atoms, one molecule, okay? You can represent this as an equation, and the equation would look something like this, right? Where you have Na1 plus, or just Na plus Cl1 minus. Notice how the 1 plus and 1 minus are superscript, they're smaller. Gives you NaCl, right? And you know the actual reaction is quite explosive, right? Sodium is so reactive with chlorine that it releases an intense amount of light and heat. And what you end up with is if you have thousands of sodium or millions of sodium versus millions of chlorine, they form this particular little cubic shaped lattice thing where those little purpley things are sodium and those bigger green things are chlorine. And that little cube, that's sodium chloride, yeah, NaCl. Sodium chloride is table salt, right? It's the stuff you and I eat all the time. And it is made up of thousands to hundreds of thousands to millions of, I guess, millions, I suppose, of little chlorine and sodium attached to each other, okay? Now, there's something to note here. If I were to put this in an actual reaction chemical equation, it would actually look more like this, right? And the difference between this diagram and the previous one is rather than having one sodium, you actually have two. And there's a reason for that. In reality, it's not that one sodium atom will interact with one chlorine atom, it's that two sodium atoms will interact with a pair of chlorine atoms. You don't really need to know why at this stage. All you need to know is that this pair there, they mean slightly different things, right? The two here, the big two, Na, represents two of these separate ones, whereas the Cl are attached to one another. In fact, you know, if you were to look at chlorine gas is actually every two molecules joined together, and that forms Cl2, right? You know, as a side note, this is covalent bonding. This is a different type of bonding. And what you're getting is the Na are going to interact with each other, and they're going to form two separate NaCl. So that's why you have two Na1 plus Cl2, the little 2 down the bottom, gives you two NaCl. Right? And you're going to say to me, Mr. Tran, what on earth are these big and small numbers here? Why is there a big number here but a small number there? And why isn't this 2 in front of the chlorine like the rest of them, right? It's because the numbers mean different things when they're in different positions, okay? The big number represents the number of compounds, number of separated pieces in the reactant section or in the ingredients section, right? So there's 1 and there's 2, and that's why it's 2, okay? Cl, however, they're joined together, right? So you use a little number to show that these two Cl are joined together. It still tells you that there's two Cl molecules, but the two of them are attached, right? And then the NaCl, see, Na and Cl is 1 and 1, but there's 2 in front of it. So that's, you know, there's one NaCl here, one NaCl here. So in total, there's 2 NaCl, right? So that big number, you multiply that by everything that's inside the chemical formula, yeah? There's an Na, and then there's Cl, so there's 2 of each, right? So that little number is the number of atoms that are present in the compound. The big number is the number of compounds, okay? Let's do another one. So let's look now at magnesium, and oops, I forgot to make the arrows appear, so I'm just going to keep going. Magnesium is 282, and that's what it looks like. Now, instead of 1 electron in the outer shell, 1 valence electron, magnesium has 2, right? Which now means that rather than giving away 1 valence electron to become stable, it's going to give away 2 valence electrons to become stable. And so magnesium will turn into Mg2+, and that also is an ion, right? It's a positive ion, once again, in the section that gives away. Chlorine sorry, not chlorine, oxygen, on the other hand, has a configuration of 2, 6, right? Which means oxygen has 2 in the first shell and 6 in the outer shell, and it's going to take both of the electron that magnesium is going to give to it, right? And so now you get a chemical reaction that looks very similar to the previous one, except this time it's Mg2 plus O2 minus gives you 2 MgO. You got 2 of each molecule, okay? And if we go back to the periodic table, you're going to see magnesium sits there in group 2, and it's going to give away 2. And then oxygen is up in this little corner here, and it has 6, and it's going to take 6, okay? So hopefully that gives you an idea of how different molecules will interact with each other, how different atoms are going to interact with each other, that the ones on this side that give, they're going to give their electrons away, and the ones on this side that take, they're going to take the electrons away, okay? Now, probably one of the burning questions that you're going to have is, how do I know how many electrons an atom is going to give or take, right? How did you know that sodium was going to give 1? How did you know that chlorine was going to give 2? How did you know, that chlorine was going to take 1? How did you know that magnesium was going to give 2 and that oxygen was going to take 2? There is a pattern for it, but that's the advanced science part. So in this case, you actually don't. Instead, you get a basic ions list, right? This list tells you what these atoms and molecules are going to become, right? And so we're going to use this list as a reference point for all of your interactions when it comes to chemical reactions. You're going to find out where each of these guys turn into ions, right? So you see potassium turns into 1 plus, and we're going to assume that that's always going to be the case. Barium is going to become 2 plus, calcium is 2 plus, copper is 2 plus, magnesium is 2 plus. Whereas you got all the ones on this side, they're going to become minuses, right? Chlorine is over there, oxygen is 2 minus, iodine is 1 minus, fluorine is 1 minus, bromine is minus, and so forth and so forth. All right, that list is going to be for your reference. Even in a test or an exam condition, that reference list will be available for you to work with. Okay, so hopefully that makes a bit of sense, and I'll catch you guys on the next lesson when we look at chemical equations. I'll see you later.